Okay, Algebra 1, Lesson 3.1. We're now going to start actually solving our equations, okay? And we're starting with just addition and subtraction. Okay, so there are things called transformations that we can do on equations that are going to produce an equivalent equation. Right, because our ultimate goal is to get our variable by itself, but you can only do that by making sure that what you're doing is equal to what you started with. Okay, so just to kind of see what we mean by equivalent equations. X plus 5 equals 7 and x equals 2 are equivalent equations because they both are true with the same x value. Right, because if we look over here, what it's saying is what number plus 5 gives you 7? Well, 5 plus 2 gives me 7. So we can say that x is 2. Okay, and x is 2 over here. So these are equivalent equations. So what we want to do is we want to think of an equation as having two sides that are in balance. Okay, kind of like a scale. So here's that equal sign in your equation. You have something on the left and something on the right. And they're equal, they're the same, okay? We have to keep them balanced. So whatever I'm gonna do to the left, right, if I am at the grocery store and I add an apple, then I have to add an apple to the other side to keep it balanced, okay? If I take that apple away, then I wanna take the other apple away because I wanna keep it balanced. Or a teeter-totter, okay? If I put something on the left, it's going to make it go lower than the right. So I need to keep them balanced, okay? So transformations that produce these equivalent equations are on page 132 of your book. And they are that you can add the same number to each side. All right, so x minus 4 equals 11. We're saying it's in balance. So if I add 4 to both sides, okay, I kept it balanced. I can subtract the same number from both sides. So if I have x plus 4 equals 11, subtracting 4 from both sides, I would get x equals 7. They're equivalent. You can simplify one or both sides. So think of this one as x equals 11 minus 8. I can simplify 11 minus 8 and get x equals 3. And you can interchange both sides. All right, so all that one really means is if x equals 5, then 5 equals x. I just flipped them, okay, and they're equivalent. They mean the exact same thing. So we're starting with this adding and subtracting idea. Keeping it in balance, add the same number or subtract the same number, and your equations are balanced. Okay? So when it comes to solving, we have to use inverse operations. And what it means for inverse operations is we're looking for operations that undo each other. Right, so for example, addition and subtraction are inverses. Okay, if I take 2 and add 3, then subtract 3, I get 2. The subtraction undid the addition. If I have 5 and subtract 4 and then add 4, I still end up with 5 because that addition undid the subtraction. Okay, so solving equations with just addition and subtraction, first you identify the operation that's being performed. Okay, then you use the inverse on both sides. The goal of solving is to isolate your variable. Which means I want to get it by itself. I want to have one x on one side, or one y, or one z. I want that variable completely by itself. Okay? So in chapter 3, we are just dealing with linear equations. Okay, what that means is your variable is raised to just the first power. It's not in the denominator. It's not inside a square root. Not inside an absolute value. Okay, you just have x or y, right? You might have 3x or 3y, but you don't have x squared. You don't have the square root of x, okay? So we're just looking at linear. So we want to solve x minus 9 equals negative 17, right? So to solve, what that means is we want that variable completely by itself, okay? So we look at our equation and we say, all right, here's my x, so here's my variable. What I'm doing to it is I'm subtracting 9. So to undo that, use the inverse. So the inverse of subtraction is adding. So I want x by itself. So I subtracted 9. So to isolate it, I'm doing the inverse of that. I'm adding 9. But we have to keep the equation in balance. So I added 9 to the left. I'm going to have to add 9 to the right. So x minus 9 plus 9 is just x. Right? That minus 9 plus 9 canceled out. Then I have negative 17 plus 9, right? Which we said 17 minus 9, and then attach the negative because 17 is negative. So x is negative 8. Okay? All right. The next equation that we're looking at would be negative 11 is equal to n minus negative 2. Right, so one of the things we can do is we can simplify one or both sides. So if I look at the left, I have negative 11. There is nothing I can simplify. But if I look at the right, I have n minus negative 2. So when you subtract a negative, that turns into addition. Okay, then I can see that I have my variable and I'm adding 2. So that's my operation, is addition. So to undo addition, you use subtraction. So I'm going to subtract 2 from both sides because I have to keep it in balance. Okay? So I have n plus 2 minus 2. The plus 2 minus 2 cancels, so I get n. And then I have negative 11 minus 2. Well, it's a negative minus something, so I'm going to add them and then add the like variable, or the like operation. Generally, we write it as your variable first, so I'm going to use that other transformation that says I can interchange my two sides, and I get that n equals negative 13. Okay, so that's lesson 3.1. Okay, you isolate your variable to solve by using inverse operations. So if you're given addition, then you use subtraction on both sides. If you're given subtraction, then you use addition on both sides. Keeping in balance, whatever I do to one side, I have to do to the other. Okay, so lesson 2.8.